So we're talking today about tangent lines. Now, just to remind you what a tangent line is, it's a line on the outside of the circle that touches the circle in one exact spot. So it's hard to see that it only touches one spot here because it looks like it might touch in several spots, but that's just because of the thickness of the line that we get drawn and that kind of thing. So it touches in one exact spot. So today we're going to mostly talk about these tangent lines when you have two of them that touch at one point, or we're going to talk about how they compare to the radius and diameter. So the first rule says if two segments are tangent to a circle from the same external point. So do you guys agree that these two lines right here are tangent to the circle from the same external point, right? That's what it's talking about here. Then the two segments are, does anybody want to guess the relationship between this one and this one? Do they look like they might be equal, parallel, perpendicular? What do you think they are? Equal. They are equal. So we can say congruent, which really just means the same as equal. Okay? So these two tangent lines, if they go from an external point to the edge of the circle and the same external point to the edge of the circle, those two tangent lines are equal to each other. That's the first rule. Okay? Rule number 2 says if a line is tangent to a circle, then it is blank to the radius drawn at the point of tangency. Does everybody remember that that point of tangency is that one particular point where the line touches the edge of the circle? So if you draw your radius from here to there, what happened right here? It formed a right angle. Does anybody remember what we call it when two line segments form a right angle together? What do we call that relationship? Starts with a P. Yeah, it's perpendicular. But perpendicular really just means that the right angle was formed. Okay. So not only would it be perpendicular to a radius, but it would also be perpendicular to a diameter, right? If we wanted to remember that rule also. Okay, third rule today says this. If a line is perpendicular to a point on the circle, then the line is, and this is just the opposite of that, we just know that the line has to be a tangent. So if you have a line that's drawn that's perpendicular to the radius, you automatically know that that line's tangent. Okay? So here's the interesting to think about once you know that this is perpendicular. Most of the time we'll use that to form a right triangle right here and solve for missing lengths of that triangle. So that's why it's important to know that we've formed a right triangle when we have a tangent that we're looking at. Okay, so let's see if we can use some math now to do some stuff with those three rules. Okay, the first rule here says solve for x, or the first equation here says solve for x. So looking here, we're solving for x, and we know this side or this length of the tangent, and we know this length of the tangent. Does anybody remember what we said about the two lengths of the tangents? If they go to the same external point, they're equal to each other, right? We know they're the same. So we're going to say 2x is equal to x plus 12. Now that's pretty simple to solve from there, right? We're going to isolate the x's on one side. So how do I get all of the x's on one side together? What am I going to do with this x right here? Subtract it over. When I do that, I get x equals 12, and we've solved for x. Now, if you wanted to know if you were correct on that, you would substitute that 12 in to make sure they were equal to each other. So you'd have 12 plus 12, which is 24, and 2 times 12, which is 24. So we know we did our math right because it gave us two equal tangent lines. Questions on that one? All right, this next example is the same rule again. So if we have two tangent lines drawn to the same external point, we know that these two tangent lines are equal to each other. So we're going to use our algebra skills and set them equal to each other. So x plus 10 equals 2x minus 1. and we're going to solve that equation. In order to solve it, we're going to get all the x's on one side, all the numbers on the other. I always like to move my x's to keep them positive. So I find the smaller one and move it to the other side. So I'm going to subtract this x over. When I do that, I get 10 equals x minus 1. How do I get x by itself? Add the 1. And x is going to be 11. Again, if you want to check your work and see if you did it correctly, you're going to put 11 in over here. 11 plus 10 is 21. And then 2 times 11 is 22. 22 minus 1 is 21. So they equaled each other. We know we did our math correctly. Questions on that rule? That's pretty easy, right? You have two tangent lines that are external to the same point. You set them equal to each other. Okay, so here we go. Which one of these is a tangent line? Is it this top one from B to A, or is it from O to A? Which one's tangent? It's actually B to A. If we were going to talk about the name of this one, this would be a secant line, but we don't have to talk about secants in this year of math, so we're not going to really talk about them, but that's what it is, okay? So what do we know about this tangent line and the radius? Yeah, they form a right angle together there, right? They're perpendicular to each other. That's really nice to know, because if I'm looking for this length right here, I just made myself a right triangle, which tells me I can use all of the rules of right triangles. Does anybody remember a rule that will help me find the third side of a right triangle? It looks something like this. A squared plus B squared equals C squared. That rule is called the Pythagorean theorem. We've used it lots of times this year, right? Anytime we have a right triangle and we're looking for the missing side, we can use the Pythagorean theorem. Anybody remind me, or can you tell me, I guess, what this side right here has to be? What letter in my formula? So this is interesting, because Jasmine just has been sitting through my Math 3 class, and she knows that we should be calling this side B over here, right? But this one's not labeled correctly. So let's think about it for just a minute. This one's opposite the hypotenuse, or it is the hypotenuse because it's opposite the right angle. And the hypotenuse always has to be which one when we substitute it in? C. So we can do A squared plus B squared equals C squared. The C part always has to be the hypotenuse. So I'm going to go 5 squared plus X squared equals 13 squared. Anybody need to ask me a question on why that's the order we put them in? Because I'm with Jasmine, so like, don't you think if this was angle B, this should have been side B? Like, that's the way that it works in triangles. So I see Jasmine's point on that, but because this is the hypotenuse, it has to be plugged into this formula in place of C. And those of you, when you make it into Math 3 next year and you get to hear me talk about this some more, we really manipulate this formula a lot. Sometimes we call it x squared plus y squared equals r squared. Sometimes we call it, I mean, we can call it anything we want to, as long as we put that last side in as the hypotenuse. All right, I've talked a lot. Do you have it solved yet? This will be 25 plus x squared equals 169. Subtract the 25 over to the other side, and you get x squared equals 144. Square root both sides, and x equals 12 for the length of the side. Questions on how I did that? All right, one last problem then that's very similar to this one. It asked me to solve for x. And again, just a reminder here that when we have a tangent line, that line that touches the circle at a point of tangency only once, it forms a right angle with the radius. This is the radius because it goes from the center to the edge. So I have a right triangle. I need to know this length right here. Now I want to bring up a point right here to you and say, I know I can solve the Pythagorean theorem and I can find this whole length right here, right? That would be what we would find with the Pythagorean theorem. So how do I find that little piece that's missing? Does anybody know anything about this piece that goes from here to here? It's 12 because it's a radius, right? So if I find this whole length over here by doing the Pythagorean theorem, can I just take 12 off of it to find that little piece? All right, so let's do it. So what side am I looking for? I'm looking for C, right? Because it's my hypotenuse. So I'm going to go 12 squared plus 16 squared equals C squared, and I'm going to solve that. 12 squared is 144. 16 squared is, good, that's equal to C squared. So we're going to add those together. When we do, we get 400. I love it when it works out nice. Square root both sides, and I get C equals 20. That is not the number I'm looking for, though, is it? This whole side over here measures 20 from here all the way to there. I just need this X value. I know from here to here measures 12. So how much is left? 8. X has to be 8 because of the radius that I knew. All right, questions on how to do those problems?